In this video, I'll be working through the question you see on the screen here from 2025 Leaving Cert Ordinary Level Paper 1. I'm going to try and show you how to do the question, not just the solution. So pause and rewatch certain parts of the video if you need to. If you're looking for a different question from this paper or a different paper entirely, have a look at the description below. You should be able to find a playlist there or search around on my channel. Okay, let's get into the maths. Question 9 starts off with a question about someone saving money. They have €4,500. They put it into a bank and they put it somewhere and they get a savings rate of 2.8%. And basically we're asked how much will they have after 1 year, after 2, after 3, something like that. A part 1 just starts 1 year. How much will they have after 1 year? Couple of ways to do this. I'll do it the slightly slower and then slightly faster way just to show you. The way a lot of students do is they get 2.8% of this. Your calculator will do that, but really it's just multiplying this by 2.8%. Remember, 2.8% is actually, you need to divide it by 100 to get its actual number, its decimal number. So we get 0.028. Lots of students put 28 here instead of 0.28. That'd be 28%. So be very careful about that. You can put that in and you would get 126. Again, a lot of students leave this as their answer. This is not what they asked you. They asked you how much money will be in your account after 1 year. You put 4,500 in, and you didn't take anything out, so I hope there's more than that. What you found here is your interest. You need to add this onto here. So the answer would be 4,626. There's a faster way to do that. If you're going to deal with interest a lot, it's helpful to remember it. 4,500 multiplied by, instead of 0.028, 1.028. What this is doing is it's giving you the original amount, that's the 1 part, and it's adding on 0.28. which is the percentage. Put all that in and you'll get 4,626. Okay, for part 2, they pretty much ask the same thing, but how much will you have after 3 years? And remember, they're saying compound interest. You can do this a really slow way. You've done your first year. A really slow way would just do the same again every year, especially if you did it this way. Find out the interest in the second year, then add it on. Find out the interest in the third year, then add it on. Lots of students do that. It's fine. It's just a little slower. I'm going to use this method here to make it a little bit faster. That's the first year, year 1 here. Year 2 would simply be this new number, 4,628 multiplied by 1.028. And if you put that in, you would get 55.528, or to the nearest cent would be 53. So that's a little faster doing it that. But again, you could have just got 0.028, found the interest and added on. It would only take an extra 30 seconds. So we're not talking the end of the world if you did it that way. But third year, you do the same thing again here, 4,755.528. There's an even faster way I'm going to show you in a moment. Multiply by 1.028, and the final answer would be, and I've rounded this one off to the nearest cent, 2 decimal places, it's 4,888.68. The even faster way to do all this for 3 years, and maybe you can see it from what I did here. I got this number multiplied by that. I got this number multiplied by that. Really what I did from the very start, 4,500, if you put that into a bank account for 3 years at the interest rate of 2.8%, it's just like multiplying by 1.028 to the power of however many number of years, power of 3. If you put that into your calculator, you'll get the final answer in one go. And in fact, if they asked you, I wrote here 20 years, if they asked you how much would they have after 20 years, you couldn't do it by hand. You'd be there for 20-30 minutes and you wouldn't finish the exam, I would say, in time. So if you wanted 20 years, you can still do it in nearly the same time. Put all that in a calculator, and if you're interested, you'd actually have 7,817. Not that much extra. That's because it's not that great of an interest rate, really. Okay, let's go on to the next part. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Right, in B, they've given us these drawings, these three drawings, and we're missing one of them. And they want us to draw in the missing one. Sorry, they've given us actually the dots in this missing one, which is nice of them. I love questions like this because I enjoy maths. These are nice problem solving questions, but I understand students don't love these because you can't learn them. There's nothing, you can't study them. It's either you're able to do them, you're able to figure out the pattern, or you can't. We will have some maths later on in the question, but still we need to do a bit of puzzle solving. I'd say most students did this, at least this anyway. You either got the answer right or you probably put this in. This is not the full answer. Okay, it seems like it is a line, a triangle, a square. The clue is this one, all these lines in the middle. What's actually happening here is every dot is hitting every dot. There's only two dots though, so one line. Every dot hits every other dot. This one hits two things. This hits two things and this hits two things. Again, here, it's more obvious to see this one. Every dot hits every other dot. So what we actually need, if you just drew this, you're not hitting every one until you put a line across like that and a line across like that. That's the full marks there. So I'm guessing some students probably lost marks for not putting those middle two crosses in. In part 2, they want you to fill in this table here, and they've done some of it for you. Let's see. For pattern 1, this is pattern 1 here. How many dots has it got? Has 2. They've done that for you. For pattern 2, this one, how many dots has it got? It has 3. They've done that for you. They want you to fill in the rest. Pattern 3, this one here, they already drew the 4 dots for you, so you can just count them up. There's 4 dots, not too hard. This one is you can just count them up. There's actually 5 dots here. It's the last one we have to use a bit of thought for, and it shouldn't be too difficult. 2, 3, 4, 5. It's clearly going to be 6. And if we said going, 7, 8, 9, 10. So that one's not too hard. Same again for the line. They did the first one for you. How many lines are there? There's 1. For the fourth one, again, they've saved you a bit of work there, counting all these lines. There's actually 10 there. How many lines is on this one? 1, 2, 3. We can count that up. How many lines here? 1, 2, 3, 4, 5, and 6. There's 6 lines there. I guess some students would argue that this is a line and this is a line. No, there's no dot in the middle. What we're calling a line is between the 2 dots. So I guess you could argue that, but I think it was clear that they wanted 6 there. What's the last one? And this is the harder part. What's the pattern going on here? There's a couple of ways you could probably see it, and maybe you just can't see it. But the numbers goes up 2, then it goes up 3, then it goes up 4. So the next one, it's going to go up 5. The other way I sort of seen it was, this is 1 plus 2 gets 3. 3 plus 3 gets 6. 6 plus 4 gets 10. 10 plus 5 gets 15. They're both the same pattern in sort of a different looking way, but that's what's happening here. Next, they want us to find how many dots would be in the 1000 pattern. You're not going to continue this table on all the way to 1000. In pattern 1, there's 2. In pattern 2, there's 3. In pattern 5, there's 6. So in pattern 1000, there's going to be 1001. It's just one number bigger each time. How many lines there's going to be? That's a different question. They don't actually ask it, but we could probably get it. If you can get the next part, you could probably get this. So in part 4, they tell us SN is the total number of dots required to make the first N patterns. Students would hate this question, I'm sure. it's very difficult to read. It's a very maths way to read. Here's a hint, and it's something that you can help you in lots of exam questions. Try read that question again with, instead of n, with a few different numbers. We'll start with 1. S1 is the total number of dots required to make the first one pattern. We can read that. That first one pattern will be here. How many dots is needed to make that? 2. S1 is 2. I'll read that again. I'll do this 3 times. I'll read it again. Instead of n, I'm just going to say 2. S2 is the total number of dots required to make the first 2 patterns. First 2 patterns is this and this. That might have slipped up a lot of students. We're not talking about this one, we're talking about both of these now. How many dots are needed? 1, 2, 3, 4, and 5. We need 5 dots for that. S3 is how many dots are needed to make up the first 3 patterns. So we add in another 4 to this, we get to 9. I think that would have helped some students start this question off. Doesn't help you all the way though. The next clue they've sort of given you here, so they want to write out Sn in terms of n. Some students might be able to do that from this. You would have covered that in your school book, in your book, in your class, but it's quite a difficult thing to do. The clue they're giving you here is the fact that they said Sn at all. The examiner wants to help you. They want you to think of, sequence and series. They want you to think of this as an arithmetic sequence, because that's what the dots are. There's 2 dots, there's 3 dots, there's 4 dots. This is an arithmetic sequence where the first term is equal to 2 and the difference is equal to 1. The sum of the first terms, they're talking about the sum, the total number of dots, that is the sum. We're adding up 2 to get 2, 2 plus 3 to get 5, 2 plus 3 plus 4 will get 9. That's all we're doing here. We're doing the arithmetic sum of this sequence. And we have a formula for that. Sn is equal to n divided by 2 multiply, I'm trying to remember this in my head, 2 times a plus n minus 1 times d, I hope. Let me just double check my notes. Indeed, okay, minus 1. I'm always mixing up the minus with a plus for some reason. This will get you most of your marks. But remember, we know what a is and we know what d is. So let's fill it in. Sn is equal to n over 2. 2 times a is 4 plus n minus 1 multiplied by 1. Oh, well, then we can get rid of the bracket. 1 multiplied by n is n. 1 multiplied by minus 1 is minus 1. I think you might lose a mark there because we have 4 minus 1. We can simplify that a little bit. N over 2. 4 minus 1 is 3 plus n. That'll get you full marks. You can multiply this in if you want. That'll get you full marks as well. You can play around with this. But at this point, that's full marks for part 4. Before I go on to part 5, I forgot, I could see another way that you could do part 4, the Sn term. Yeah, I'll continue on with this idea. I'll write it again though. S1 is equal to, S2 is equal to plus 3. S3 is equal to plus 3 plus 4. Sn, I would accept this as an answer, and I'm guessing an examiner would have to, but although it's probably not in the marking scheme. I don't think the marking scheme's out yet, so I haven't seen it. But Sn is 2 plus 3 plus 4, and maybe you'd need a plus dot 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 and plus n. That's Sn in terms of n. This is perfectly correct. It looks very different than this, and it's not as useful as this. You're not going to be able to use this in the next part unless you know how to turn this into this, which you can, by the way. But that'd be another answer for part 4. Okay, let me clean some of this off and we'll do part 5. So in part 5, they ask you to find the total number of complete patterns in the sequence that can be made using 720 dots. This is how many dots the nth pattern needs. So if we put in, well, actually, here's a couple of ways. I just thought of an easier way to do this question. If you put 10 into this instead of n, you'll find out how many dots you need to make the first 10 patterns. And I'm guessing the answer, well, let me just cheat and look at the final answer. Yeah, you'll find a number much less than 740. Put in 100, you'll find a number bigger than 740. So you're just narrowing down where the answer is. You could probably do it by guessing 5 or 6 times. You should be able to find the correct number for this. Actually, yeah, so that's a perfectly okay way to do this. I'm going to show you the more maths way to do it. The maths way to do it is this number has to be bigger than or equal to how many dots? So n over 2 multiplied by 3 plus n. This has to be, less than or equal to 740. It's okay if you put in equals here. I think most students would have put in equals here, and it turns out an equal is fine. The number of dots does work out exactly right, but technically we should have had a less than or equals to. I'm not going to bother because I think it might just confuse some students, and it's not fully necessary here. At the end, if it turns out we did need it, we can always just rearrange things. That might sound like cheating or something, but really we're just doing the maths to answer the question. The maths itself doesn't matter what we write if we are using it to answer the question, and that's all we're doing. So whether it's an equals or a less than, you can still answer the question if you use a bit of logic at the end. Okay, so the intended way to do this would have been to write this out and to solve for n. It's a pretty hard one to solve. We could try multiplying these brackets out. So let's do that first. n over 2 times 3 would be 3n over 2. n over 2 times n would be n squared over 2 equals 740. Or we could have multiplied the 2 first, moved it across. That probably is a better way to do it. I'll do that now. I'll multiply everybody by 2. Multiply this by 2, it'll disappear. Multiply that by 2, it'll disappear. Multiply this by 2, we'll get 1480. At this point, hopefully you're starting to see this is a quadratic equation. We have an n squared. We have a 3n. I've changed these around. I've not really changed anything. This plus this is the same as the other way. If I move this guy over the equals, it becomes a minus 1480 equals 0. This is a quadratic equation that we can solve. As it happens, we can actually factorize this. A number does go in equally, it goes in nicely to this. I don't expect many students to factorize this. I didn't factorize in my head. I used a little cheat. I used the calculator because I know this number is quite small compared to this one. So the answer must be around about the square root of this. And so the square root is something like 39 or so. So I just tested a few numbers around 39 and one of them went in evenly. How I advise you to do it is the minus b formula. I'll go a little quickly because I don't have that much room. But the minus b formula would have a equals 1, b equals 3, and c equals minus 1480. And that would tell you that n is equal to minus 3, that's minus b, plus or minus the square root of b squared, 3 squared, that's 9, minus 4 times a, so that's minus 4, 4 times 1, that's minus 4, multiplied by minus 1480. So we're going to end up using square root anyway. And this is all divided by 2. You put this in on a calculator. I don't have it written in my notes, but 4 multiplied by this on a calculator would be around, I guess, 5,920. It's not actually that hard to do. 5,920 plus 9, and we put that into a calculator. And let me just check my notes on this one. No, I couldn't figure it out from my notes, so I had to go to my trusty calculator. The square root of this would be 77. So we would have minus 3 plus or minus 77 divided by 2. So that's equal to, let's see, it'd be 74 over 2. Well, let me write them out. 74 over 2, or it would be minus 80 over 2. So it would be 37, or it would be minus 40. Remember, we're talking about n. How many patterns? 1 pattern, 2 pattern, 3 patterns, 40 patterns, but never minus pattern. That wouldn't make sense. So that one's out. 37 is the answer. 37 patterns could be made exactly with 740. all that talk about having less than would be, if they had given us the number 741, we could have still just made 37 patterns and we'd have an extra dot. So that was what I was talking about there. As I do this, I think to myself that definitely the easier way to do this question was just to put in numbers into this. Put 10 in, see what you get. Put 20 in, see what you get. Put 30 in, you'd still be less than 740. Put 40 in, you'd be over it. Try 35, you'd be under. Try 38, you'd be over. Try 37, you'd find it. A bit of work in your calculator, you wouldn't have had to do all this. If you do something like that in the exam, just tell them you're doing it every time. Tell them, put 10 in, write down what your calculator said. Tell them, I put 20 in, write down what your calculator said. You'll get full marks if you do it correctly. Okay, the final part of this question 9, which I think I would categorise as probably the hardest question in this paper so far. It's not too hard of a final part though. They've given us this formula here for the number of line segments in the nth term. And they just want you to find out what B is. Now that might seem difficult, but remember we have a table. I've rubbed it out, I still have it in my notes here, for how many lines is in each pattern. Let me write it again. Pattern 1, we'll have 1 line, 2, 3, I'll put in just 5 of them. Pattern 2, we'll have 3, then 6, then 10, then 15. That's how many lines were in the drawings they gave us. What they're telling you is this equation will do the same thing. If I put 1 in here, I should find 1 out. If I put 2 in, I should get 3 out. If I put 4, and so on, we should get everything out. As it's the last part, you might expect there's a lot of work to do here. There's not really. You pick any one of these you want, or even there was a 6th one, I believe. Pick any one you want. I'll go ahead with T of 1, the first pattern. This is not the number of dots around, this is the pattern. T of 1 is equal to 0.5 times 1 squared plus B times 1. But I know the answer is 1. So forget that. This is an equation with just B here. 1 by 1 is 1. Multiplied by half is just a half. Plus 1 times B, that's just B. Rearrange this so B is on its own. Or just think here, a half plus what is equal 1? Well, B is a half, but let's do it slowly. B is equal 1 minus a half. This comes over to a minus. B is equal 0.5. That's your answer. And if you don't believe me, you could have used any one of these. Let's use 3 this time. T of 3 is equal 0.5 times 3 squared plus 3 times B. But I know the answer is 6. 3 by 3 is 9. 9 times this is 4.5 plus 3B is equal 6. 3B is equal, take this from both sides, 6 minus 4.5. 3B is equal 1.5. Divide both sides by 3 and we get 0.5 again. And you get the same no matter which one you put in. There was a clue that you'd get an answer. Oh, sorry, another way to write 0.5 is 1 over 2. And there was a clue your answer might be a fraction like this because they said B was an element of a Q. That means it's a quotient. That means it's a fraction. And yeah, they don't need it written like this though. 0.5 is perfectly fine. Okay, that's it for question 9. If you have any questions, pretty long and hard question. So if you have any questions or you see any mistakes I made, let me know in the comments, please. Do me a favor though, put in the timestamp. Saves me looking through the whole question 3 years from now when you ask your question. That'll help me out a lot. Thanks for watching and have a great day.